Hello, welcome to my channel Study Easy. Today's topic is tunnel diode. I have already uploaded video of conventional diode and Zener diode. For that I will provide you a link in a description box. Now, let me tell you first that I have mentioned some of the highlighted topics here in this tunnel diode which you need at the time of examination to write answer properly and to understand this topic successfully. Let's start with the definition. Definition of a tunnel diode is tunnel diode is a heavily doped semiconductor device. Okay, what is heavily doped? The doping inserted into the N and P type of material which is used in the diode. Like this, p-type material and n-type material both will combine to make a diode. In this both material there is a doping inserted which is heavy compared to the conventional diode, about thousands times more doping is used in a tunnel diode. Okay, this is also called as Easki diode from its inventor name which is Easki. Okay, now focus in the definition. Tunnel diode is a heavily doped semiconductor device and is used mainly for low voltage high frequency switching application. Why low voltage high frequency? Because you will learn in this topic that when you will apply low voltage in input, you will get high frequency switching, means suddenly at a low voltage you will get a raise of a current in starting only. So this is mainly used for low voltage high frequency switching application. It works on the principle of tunneling effect. Okay, now to understand this tunnel diode, you will need few of the topic throughout this understanding of this diode in a detail is punch through and tunneling. These 2 points you need to understand in a detail, which will makes you learn this diode very easily. What is punch through? Okay. Punch through means carrier movement, or we can say when a electron is moving from one to other. You know that electron will move from valence band to conduction band as well as from p type to n type at the time of biasing is applied. So punch through is what? When you will give a bias, electron will move faster. Fast movement of current at low input voltage punches of electron from anode to cathode. It means punch through. Now, what is the meaning of tunneling? Tunneling is what? Charge carrier should climb over the barrier. Okay, what is climbing over a barrier? If you want to reach from one to other point, if you have one fixed destination point and a starting point, at that time you need to move from, or you need to travel from one to other side. Same way electron also need to travel from one place to another place, means anode to cathode. For that they need to get a proper biasing, or they need to work out. But here in a tunnel diode, at the very low input voltage, a electron flow is moving from anode to cathode very fast. That's why we can say, rather than climbing over the barrier, it is punching the conduction at very little energy due to the less depletion width and high doping, means it is having more negative side or more electron at the valence part. That's why, okay, this is because of doping. So electron movement will be faster at a low input. This is the symbol of tunnel diode. Equivalent circuit. Okay, the main point that you need to understand in a tunnel diode, or mainly question that comes in an examination of tunnel diode, is What is the VI characteristic of tunnel diode? VI characteristic very important of a tunnel diode because it is somewhat different than the other diodes. See, this is the voltage, and this is the current part. At the time of when you are applying a voltage from 0. Okay, let me tell you first, this is the forward bias part and this is the reverse bias part. How? As when you apply a source to the diode, always a source will give a positive cycle first. It means a positive voltage. This is a line of x-axis which gives you a positive value, and here we are putting the voltage over here, so you will get a positive voltage here. So in first quadrant you will get a forward bias result, as well at the negative voltage means negative cycle, it means a reverse bias. So in a third quadrant you will get a reverse bias effect. So for the reverse bias and a forward bias operation or characteristic is, in forward bias you can see more electrons are present in n sides, so as and when input is given, see here, so many electrons are present, this all electron will move with the help of biasing from p to n type, from p valence band to the conduction band, and from conduction band to the valence band. Means a movement of electron will take place at the time of voltage we are applying. At a small or a little input voltage, a current will move very highly to its peak value. As and when it reaches to its peak value or punch through effect take place, the current that you will get will be the maximum or a peak current. After that, peak voltage. This is the peak voltage at where you will get a maximum value of current. From that, your current is decreasing, you can see. This A to B portion means this whole portion is said as a negative resistance. Why? Because here a voltage is increasing in compared to current is decreasing. How this take place? It is taking place as you are getting maximum current over here. It means all the electrons move from the one part or anode to cathode with a very fast movement or a punch through effect or a tunneling effect. But after reaching maximum current to the cathode part, the leftover electron needs to move or needs to cover the depletion region. This is the depletion region. If this electron wants to move from P to N type, they need more voltage because their flow is already gone. That's why this current is decreasing compared to the voltage. Less number of electron is moving, that's why the current is decreasing. This part is called as negative resistance. As and when it reaches to the valley voltage, as and when it reaches to the valley voltage, this valley current boosts up and work as a conventional diode. We all know that conventional diode or a simple diode works in a forward bias. As and when you give an input voltage, it will gives you the output as it is. It means it will work as a closed circuit. So same way, after a valley voltage, a tunnel diode will work as a conventional diode. Up to that, this peak voltage and a valley voltage, this region is more important to understand, which is negative resistance. Hope you understand this. As well, in a reverse bias, if you see, then as voltage increases, the reverse bias will gives you the output same as the conventional diode in a forward bias. Same as the conventional diode gives output in a forward bias region as like this. In reverse bias too, it will gives you the same output in tunnel diode. What does it results as? A tunnel diode is working in both forward region as well as reverse region. Now let's move towards the application. It is having ultra high speed switching because at low voltage it is switching from peak to the valley voltages. Logic memory storage device, satellite communication equipment, relaxation oscillator circuit due to its negative resistance part, FM receiver due to its low voltage part and high current with low power. Now let's move towards the advantages and disadvantages. Advantages are low cost, low noise, simplified circuit, high speed of operation as we understood. Disadvantages: low output voltage, swing and being a two-terminal device. As a two-terminal device, it is having a low output voltage. Next disadvantage is no isolation between input and output circuit. How? Because as and when we give an input, the output is changing over very rapidly to up to down. Friends, hope you understood this complicated tunnel diode. Thank you for watching. If you understood this properly, then please subscribe my channel for more such informative videos. Thank you.